Right. Guys, today we are going to discuss one of the very most important lesson in the first lesson, right? So, up to now, we have completed the discussions of units, and then we were discussing about the dimensions, right? So, as I mentioned on the last day, there are three main functions or three importance in the dimensions, right? So let's recap the things that we learned in the last day. So what are the importance of dimensions? First one is we can able to obtain the accuracy of an equation, right? Then the other thing is we can able to obtain the a dimension of we can able to obtain the dimensions of a constant, right? We can able to obtain the dimensions of the constant by using dimensions, right? The other thing is we can able to derive the equation by using derived equations by using dimension analyzing, right? So today we are going to discuss about this topic, right? Because it is one of the most important lesson um, in this first lesson, right? So, right. So today, just put the topic as the relationship between two physical quantities, right? The relationship between two physical quantities. Because before come to this topic, we have discussed a simple thing which is related with this under this topic, right? Right. So the topic is the relationship between two physical quantities, right? Okay. Now let's take an example. Now we are going to discuss about the relationship between two physical quantities, right? Right. So guys, now if we consider the relationship between two physical quantities, it can be into three categories or it can be three types, right? First one, it can be a direct, it can be a direct proportionate, direct proportionation. It can be a direct proportionation. I will explain everything, right? The second one is it can be a inversely proportionation. It can be a inversely proportionation. The third one is there's no relationship between no relationship between there's no relationship between, right? So these are the three types of relationship between two physical quantities, right? So let's clear this one. Let's assume that now now uh, let's assume you are arrange a birthday party, right? Now let's assume that you have arranged a birthday party, and let's assume that each guest uh, is taking a gift for you, right? Let's assume that each of the participant is bring a gift with them, right? So when the number of persons is increased, when the number of heads is increased, when the number of heads is increased, what happened to the number of gift? Number of gift that you obtain, it's also getting increased, right? So when the number of the guests increase, what happened to the number of gifts that you obtain? It is also getting increased. So likewise, guys, direct proportionation mean, let's assume that there are two physical quantities as A and B. So if there's a direct proportionation, what will happen when the one of the physical quantity getting increased, the other one is also getting increased, right? So this is called as the direct proportionation. On the other hand, it can be explained as when the A is getting decreased, what happened to the B? It is also getting decreased. So this is the meaning of direct proportionation, right? So this is the meaning of the direct proportionation. What will happen in the direct proportionation? The one physical quantity is getting increased, the other one is also getting increased. So as mentioned in the example, let's assume that when the person which is participated to your party is increased, the number of gifts that you given is getting increased. So likewise, these called as the direct proportionation, right? This is the meaning of the direct proportionation, right? Right. Just give me one. Right. So when we come to the inversely proportionation, the inversely proportionation means when the one of the physical quantity is getting increased, what happened to the B? It is getting decreased, right? So let's take an example. So let's assume that now if some of you is one of your parents is brought in a pizza for you, right? So let's assume that one of your father or mother is brought a pizza for you, right? So what happened now? Let's assume that if the two persons is willing to taste this pizza, then let's assume that this pizza is consist of 8 slices. Let's assume that this pizza is including 8 slices, right? So let's assume that if there's if there's two persons, uh, how many slices will you get? You will get nearly 4, isn't it? So let's assume that if there's a 4 persons uh, is willing to eat this pizza, then one of you is get only 2 slices. So likewise, in this example, when the number of persons is increased, uh, the slices which is given for each person is getting reduced, isn't it? So likewise, so these example can be considered as a inversely proportionation. When the one physical quantity is getting increased, what happened to the other? It getting decreased. On the other hand, we can able to consider the reciprocal. That is, when the A is getting decreased, what happened to the B? B is getting increased. So there's a opposite relationship between A and B. So in this instance, we are considered that this relationship is considered as the inversely proportionation, right? So this is the meaning of inversely proportionation, right? So likewise, uh, in some instances, there's no any relationship between considering physical quantities, right? So that is, so even when the A is increased, there's no any effect to the B. Even when the A is increased, there's no any affect to the B. That means there's no increase or decrease. So this can be, this is considered as the no relationship between two physical quantities, right? So likewise, there are three types of relationship between two physical quantities. That the first one is direct proportionation, the other one is inversely proportionation, the third one is there's no relationship between the considering physical quantities, right? Okay, right. So this is the initial thing that I want to highlight, right? So what is what is the initial thing? That is, there are three types of relationship between two physical quantities, right? So let's discuss some further details about those categories, right? So guys, now if there's a direct proportionation, if there's a direct proportionation, it can be represent as A directly proportionate to the B into the power of 1. Or it can be, now guys, just keep in mind that these are just examples, right? These are just example which can be represent the direct proportionation, right? And A can be proportionate to B into the power 2. And A might be proportionate to the B into the power of 3. So likewise, it can be take any relationship between these two. So this is the way that we represent the direct proportionation, right? And this power can be changed, right? This power can be changed. It can be 1, it can be 2, or it can be 3, or even it can be a fraction, right? So whatever it is, so these are the representation of direct proportionation. So let's move on to the inversely proportionation. So inversely proportionation can be represented as A proportionate to 1 over B into the power of 1, right? So I think you might get some nervous regarding the how should we obtain this kind of expressions, right? So guys, don't be afraid, right? These are just examples because the only thing is you have to get into your mind is the conclusion of this lesson, right? So you might get understand these stuffs or not, but however, only the thing is you just only need to grab the final conclusion of these uh, lessons, right? Okay. Now inversely proportionation can be represented as A proportionate to 1 over B1, or it can be A inversely proportionate to B into the power 2, or it can be represented as A is proportionate to B into the power of 3, right? So these are the some of the way that we represent the inversely proportionation, right? So if I take uh, this symbol into the nominator, then it can be represented as, so when it's come to the nominator, you know that the power is getting, the sign of the power is getting reversed, or it's getting opposite one. That means then it can be represented as B into the power minus 1. This can be represented as A proportionate to B into the power minus 2. This can be represented as A proportionate to B into the power minus 3. Right? Okay. The other one is, if there's a no relationship between two physical quantities, it can be represented as A proportionate to B into the power of 0. If there's a no relationship between two physical quantities, it can be represented as A proportionate to B into the power of 1. Right. Okay. Now the question is, just leave the answer in comment section. What is the value for D into the power of 0? What is the value for D into the power of 0? Just react, or just right. What about others? the question is, what is the numerical value in the b into the power of 1, power of 0? Or if I ask this one in this way, okay, what is the value of this expression? If you consider any zero power of a term, it can be equal to, it is equal to 1. But keep in mind that, let's take another example. 2 into the power of 0. What is the answer? It should be 1. So keep in mind that the zero power of any numerical value is equal to the zero power of any numerical value is equal to 1. So likewise, so then if there's no, then so this is the way that we represent the no relationship between any physical quantities, right? So this is the one kind of way that we note the no relationship between two physical quantities, right? So keep in mind that instead of b naught, b into the power naught, it can be considered as 1, right? So however, these are just simple things that you need to know, right? So I think you might give these examples, right? So this is the guys. This is the conclusion of this the all theoretical thing. This is the thing that you need to highlight, right? Okay. Now, if we consider relationship between any physical quantities, you might notice that this it can be represented as a into the power a into the a in proportionate to b into the power of x, right? So this x can be a positive value 1, 2, 3 likewise, and this x can be negative values, and also this power can be 0, right? So this is the only thing. So if you go through these examples, you can able to figure out that this proportionation, if I represent it generally a proportionate b into the power of x, then x can be positive values, or it can be negative values, or it can be a 0, right? So then if I represent the relationship between any physical quantities as a proportional to b into the power of x, this x can be positive values 1, 2, 3, blah blah blah, or it can be 0, or it can be negative values -1, -2, blah blah blah, right? Okay, so guys, this is the final conclusion of this theoretical point. That is, if you asked to build up relationship between two physical quantities, commonly or generally, it is represented as a proportionate to b into the power of x, and x can be a negative value or positive value, or it can be a 0, right? Okay, just guys keep in mind that these are just examples to represent each categories, right? But I explain those stuff because then you can able to clear this conclusion. Otherwise, if I write down this one straightly, then you can able to you can't able to understand anything. What is the meaning of the, how should we obtain this x? So by considering these examples, we can able to figure out the way that we obtain these expressions, right? So this is the, so that's why I wrote down these examples. Normally, you don't need to worry about, you don't need to find the way that we obtain this equation, right? But in physics, it's a logical one, right? So that's why I explained those stuffs. Right. So let's go forward with this theoretical point, right? Okay. Now let's take an example. Assume that now if you are given two physical quantities, that is, suppose that force. Let's represent the force as F and now let's assume that now you need to represent the relationship between force and the velocity, right? So these are two physical quantities, right? Force and the velocity. Now, in order to obtain to build up the relationship between force and the velocity, we can represent this velocity and this relationship as F proportionate to b into the power of x. That's it, right? So let's take another example. Force and the pressure. Now let's assume that you need to build up the relationship between force and pressure. So it can be represented as for F proportionate to P into the power of Y, right? So this X, Y, this power can be any integer value, right? Or it can be negative, it can be a zero, or it can be positive values. So this is the way that we write down the relationship between two physical quantities, right? Okay. Now, there's another thing that I want to highlight, that is, now you know that how should we represent or how should we write down the relationship between two physical quantities, isn't it? By considering this proportionate sign. And uh, so I have told you that a term called constant, right? So we have find the units of a constant, and we have find how to obtain the dimensions of a constant. So likewise, we have learned some of the things which is related with the constant. But however, you don't have idea about how to obtain constant and what's the meaning of this constant, right? So previously I told you that I will explain it later, right? So now I am going to give you just a brief idea about the constant, or how should we put the constant to a equation, right? So let's represent that. Let's call that A and B are two physical quantities, right? Just keep in mind that A and B are two physical quantities. So likewise, force and velocity, or force and pressure. So likewise, A and B are two physical quantities. The relationship between these A and B can be represented as A proportionate to B into the power of x, right? Okay. Now there's a proportionate sign. To exclude proportionate sign, proportionate to exclude proportionate sign, we use uh, a particular mathematical procedure, right? So that this is the way we put a equal sign and a constant, right? So keep in mind this. To exclude proportionate sign, that's the way that we this is the mathematical way. But what is it? By applying a equal sign and a constant. Guys, normally we represent constant as k, right? That is not the exact one, but normally, generally we use k to represent the constant, right? So to exclude the proportionate sign, what is the thing that we need to do is we put a equal sign and a constant, right? To exclude this proportionate sign, what I'm doing is, instead of this proportionate sign, I'm substituting a equal sign and a constant, right? So this is the way that we obtain a constant for a given equation, right? So this is the way that we apply constant for a given equation, and this is the plot behind the constant. To exclude the proportionate sign, we use equal and a constant, right? Okay, I think let's write down these things. Just just put a star mark and write down these things. Guys, first of all, raise your hand if you clear this enough. If you clear this enough, just raise your hand. Just copy those stuff. Right. Okay. Now, now we have idea how to build up the relationship between two physical quantities and how to apply a constant for a given relationship, right? Okay. Now let's put the topic. Now we are going to discuss now. We were discussing about the functions of the dimensions, no? Right. So just put the number 3 and just write down the topic as, this is the one of the function of the dimensions, right? Just put the topic as derive equations, derive equations, derive equations, derive equation by using dimension analyzing, by using dimension analyzing. By using dimension analyzing. Right. Okay. Now we are going to become a little scientist, right? So we can able to derive equations for a given instances, right? Okay. Now I will explain this topic by using a example, right? Okay. Just put an example as This is the first example. The force within bracket capital F, within bracket capital F, force asserted on an object, asserted on an object, the force asserted on an object the force asserted on an object is depend on the force asserted on an object is depend on following factors following factors in the below rule. First one, mass within bracket simple m, mass of the object, mass of the object. Second one, acceleration, acceleration within bracket simple a. Right. So these are the two factors which is depend the forces exerted by an object. Right. Just draw this diagram. Let's assume that this is an object which is kept on a surface, and the mass of this object is m, and we are applying a capital F force on this object, and it is experienced an a acceleration, right? So this is the thing that we just copy this diagram under this question. Right. So in the next rule, obtain an expression obtain an expression for the force within bracket capital F, for the force within bracket capital F experienced by the object in terms of m and a, in terms of simple m and a, simple m and a. Right. Within bracket just put this one, constant of proportionality constant of proportionality is equal to 1. Constant of proportionality, that is K, equal to 1. Right. Okay. Guys, you don't have any idea what we are going to do, right? But even though, just go through the question. Just go through the question. Just find out the idea of the question, right? Right. Okay. Now, I explain this theoretical point by using these questions, right? Because normally, I'm first of all, I'm explain the theoretical background and then go to the questions, right? So, but even though I use something a different method to convince these theoretical points, right? Okay. Now, if you go through the question, you can able to figure out that the force exerted on an object, the force exerted on an object is depend on two factors, right? It is depend on two factors. First one is mass, the other one is acceleration. So that's mean the F is depend on mass and the F is depend on acceleration, right? So then we can able to obtain an relationship between force and the mass and the force and the acceleration. So if I write down the relationship between the, so that's mean by go through this question you can able to figure out that force is depend on two factors now. So then let's build up relationship between these two physical quantities, right? So then if and the relationship between F and M can be represented as F proportionate to M into the power of, let's call it as X, right? So this can, the relationship between force and the mass can be represented as F proportionate to M into the power of X. The other one, that is force and the acceleration, can be represented as F proportionate to A into the power of Y, right? So this is the way that we uh, write down the relationship separately between these physical quantities, right? So let's call it one as the first one and this one as the second one. Okay. Now, if I write down the equation by considering both of these, we can able to written it as F proportionate to M into the power of Y, then, sorry, M into the power of X and A into the power of Y. Right. So just raise your hand if you clear this enough up to this level. Just raise your hand. This is just a simple thing, right? The only thing you have to copy the data which is given in the questions. Right, great. Okay. So this is the first step, right? So this is the first step. Then in the second step, now there's a proportionate sign, isn't it? There's a proportionate sign. Then let's exclude propo let's exclude proportionate sign, right? So what is the way that we exclude the proportionate sign? By you applying equivalent and a constant. By applying equivalent equal sign and a constant, we can able to exclude the proportionate sign. Right. So this is the way that we obtain the relationship between f and m and a. Right. So even though there's a issue, so even we build up this equation, we don't have an idea about the value of the x and y, right? Even though we build up an equation, we don't have an idea about the x and y, right? So now we are going to obtain a value for a numerical value for x and y by considering dimension analyzing, right? So this is the way that we apply the dimension in these questions, right? Okay, let's consider it as third step. This is the third step, that is the third step is substitute the dimensions, right? The third step is substitute the dimensions for this obtained equation. Guys, keep in mind that, just keep in mind that when you substitute in the dimensions for this obtained expression, just ignore the constant, this constant. When you substitute in the dimension for this expression, just neglect the constant, right? Just neglect constant, because you don't need to worry about the constant, right? Okay, now this is the obtained equation. F equal k m into x and a into the power of y, right? So just substitute the physical quantities except the constant, right? So F represent the force, right? So guys, what is the dimensions of force? That is m l t minus 2 equal, just neglect the constant. Then m represent the mass. So what is the dimensions of mass? It is obviously capital M. And just put this power also. A mean acceleration. So then acceleration can be substituted as LT minus into 2, but just don't forget to put this power y, right? Okay. Now here we substitute the dimensions by neglecting the constant, right? So I think it is clear up to now. Okay, in the fourth step, you need to analyze the dimensions. Guys, analyzing mean, now in this expression, there are three types of dimensions, isn't it? What are they? M, L, and T, right? Okay. Now, just consider in dimension analyzing. Let's consider each dimension separately. So first of all, I'm going to consider about the dimensions of M, right? So in dimension analyzing, this is the thing. In dimension analyzing, you have to do is equalize the indices right hand side and left hand side. Okay, just observe the way these things, right? Okay, now let's take capital M, and in if now if you're going to consider the M, you have to only considering about the index of the particular dimensions, right? Now in the right side, sorry, in the left side, this is the M, right? So what is the power in the left side of M? power mean today what is the power in this instance? That's mean 1, isn't it? Normally we don't put 1, we only use m, right? But keep in mind that if you ask the power relevant to m, that is obviously equal to 1, right? Okay, so in dimension analyzing, you have to equalize the indices right side and the left side. So in the left hand side, this LHS mean left hand side, RHS mean right hand side. Okay, in the left hand side, what is the index of m? It is equal to 1, isn't it? In the right side, this is the only place where the m is m can be obtained, right? So guys, what is the index of m in this instance? What is the index or what is the power? It is the power is equal to x, isn't it? Then 1 equal to x, right? Okay. Then let's move on to the other physical other dimension, that is L. Okay. Now we have to do is equalize the power in the left side to the powers in the right hand side. Okay. In this expression or in this expression, we can able to find out L at this in this point. Then okay, what is the power of this L? What is the power of this L? It is obviously 1, isn't it? So in the right side, we can able to find the L inside this bracket. So what is the power in this L? That is obviously 1. Even though this 1 should be multiplied from y. That's mean the uh, index of the L in the right side is equal to 1 equal to y. So that is obviously y, isn't it? Okay, then we have obtained a value for y also. Then let's consider about the t. So in the left hand side, what is the index of the t? That is -2. The power of the t is -2. On the left hand, on the right hand side, we can able to find the t inside the bracket. Here the power is -2. Even though this -2 is multiplied by y, then minus 2y, then we can able to obtain that y is also equal to 1, right? So both these expression give the same value for y. Okay, now just raise your hand if you get this dimension analyzing procedure, or if there's any issue, just let me know. Is that clear for you guys? Just raise your hand. If it is any doubt, just let me know, right? Don't be hesitate. Right. So what about the others? Right. So then, now we have obtained an equations, right? So now we are going to so this is the final part of this answer. That is, previously we have obtained that equation, that is f equal k m into the power of x, a into the power of y. So we did this dimension analyzing procedure to obtain a value for x and y. So we already have obtained a value for x and y, that is 1 and 1, isn't it? So then let's substitute the guys. I will write this the final step in this inside this box, right? So the fifth step is, now we have obtained that x equal to 1 and y equal to 1. Then, so then let's substitute this value for that obtained equation, that is f equal k m into y, a into the power of y. And the question is mentioned that the constant of proportionality, that's mean k is equal to y, is equal to 1. Then if these expressions can be obtained, that is f equal ma. Okay, so this is the procedure that we obtain this equation. I think you are familiar with this equation, isn't it? F equal ma. We learned this equation when you were in, grade 10, isn't it? Right. So this is the way that we use, that we so this is the way that we obtain the equations, right? Right. So I will explain this procedure again. Then the first thing that you need to do is just write down this kind of just a simple diagram. The main physical quantities and their dependent factors. Then obtain some relationship between the given physical quantities and their the factors, right? So that in this question, forces depend on M and A. So then obtain two relationship between F and M and the F and A. Likewise, you can able to use this X or Y, or you can use any kind of words, right? Okay, then the other thing is just write down by combining these two equations, right? Because both of these equations giving an idea about the force. So then force proportionate to m into the power of x and a into the power of y. Then the second step is exclude the proportionate sign by applying equal sign and a constant, right? Okay. The third step is, guys, you have to substitute the dimension, that the equation that you obtained and in this point, right? So when you substituting, just neglect the constant, that's mean k, right? Then just neglect the k and substitute the dimensions for the other physical quantities, and don't be forget to put these powers, right? Then dimension analyzing. So in the dimension analyzing, the thing is that you need to do is you have to consider each dimension separately and equalize the powers in the left side to the powers in the right hand side. So this is the only thing that we need to do. Okay. Okay. Right. Just copy these procedures very clearly. This is one of the most important topic under this first lesson, right? You definitely have to be familiar with these steps. Guys, in this step, you have to equalize the indices, mean powers of the relevant dimensions, right? Powers of the relevant dimensions. Right. Okay. Now let's move on to the second example, right? This is the second example. Right. The potential energy, the potential energy within bracket capital E, the potential energy within bracket capital E of an object, the potential energy of an object is depend on the following factors. The potential energy of an object is depend on the following factors. First one, mass, within bracket simple m. Second one, gravitational acceleration. Gravitational acceleration within bracket g. Guys, gravitational acceleration means the same acceleration that we learned, right? Same acceleration. Gravitational acceleration within bracket simple g. Third one, height within bracket simple h. So these are the factors which depend the gravitational field of an object. First one is the mass, simple m, gravitational acceleration, symbol g, and the height. Right. So in the next rule, obtain an expression for the potential energy. Obtain an expression for the potential energy in terms of in m, g and h. You have to obtain an expression for the gravitational. You have to obtain an equation for potential energy in terms of m, g, and h. Right? Within bracket. Constant of proportionality, that is k equal to 1. Right. Okay. Just go through the questions and obtain an equation for gravitational potential energy. Right. Try to get the an equation and leave me a message with your obtain expressions, right? Right. First of all, let's find out this. See whether the way you initiate this question is correct or not. Right. So according to these questions, potential energy of an object is depend on mass of the object, gravitational acceleration, and the height of the object. Right. So the next you have to build up relationship between E and M, E and G, E and H. Right. So let's assume that E is proportionate. So the relationship between E and M can be represented as E proportionate to M of the power of X and E proportionate to G into power of Y and E proportionate to H into power of Z. Right. So then, by combining these three relationships, you can able to obtain a single combined relationship as E proportionate to M into the power of X, G into the power of Y, and X in H into power of Z. H into power of Z. Right? Right. So guys, this should be your first step. And the second step is you have to exclude the proportionate sign. Then what you need to do is you have to put a equal sign and a constant. Then write down the rest of the expression. Right. Okay. So this is the obtain equation. The next step should be substitute the dimension with neglecting the constant. Right. Just continue it. Right. So let's go through this third step. That is, now we have to substitute the relevant dimension for this expressions, right? So E mean energy, or it is the potential energy. You know that, guys. Now I have told you that how to derive the dimensions for a particular physical quantities, right? So first one is you can able to obtain the physical quantities. You can able to obtain the dimensions by considering the relevant equation. The other thing is you can able to obtain the dimension of a particular physical quantity by considering the units, right? Okay. Now, however, now you need to obtain the dimensions of energy, right? So energy. Now there's a equation for energy, that is potential energy, that is mgh, isn't it? Right. So by considering this equation, let's try to build up a dimensions of energy. Right. Here M mean mass, G mean gravitational acceleration. That's mean L T minus into L T minus 2. H mean length, it is L. So this should be the dimensions of energy. Right. So you have to substitute this dimensions for the energy. MLT ML into the power of T into the power of minus 2 equal, just neglect the constant, then mx. Here m mean mass. So this should be substitute m into the power of x. Then gravitational acceleration. Guys, I have told you that gravitational acceleration means the same acceleration, right? So the LT minus 2 into the power of y. Then h mean length, so L into the power of x. So this is the equation that we substitute the dimensions for this each physical quantity, right? So the next step should be the analyze the dimensions, right? Okay. Now let's first of all let's consider the dimensions of capital M. So in the left side, you can able to figure out that m, the dimension, the power of m in the left side is equal to 1, isn't it? Or the in this index of this m is equal to 1, isn't it? So the 1 is equal to, on the right side you can able to find out the m only in one place, isn't it? So then the power of this m is equal to x. So the x equal to m, right? So in the next step should be the L. So in the right side, so in the left side, you can able to figure out that the index of the L is equal to. So 2 is equal to, on the right side, you can able to find the L in two positions, isn't it? First one at this point, and the second one is in this point. So you do have to consider the both powers of the two instances, right? So then at this point, the index should be y 1, and it should be multiplied by y, isn't it? So 1 into y. On the other side, this L having a power of Z. It is written as Z, right? Plus Z. So then, if I further simplify it, y plus Z. So you can able you can able to figure out that we can't able to obtain a value for y or Z because it looks like a simultaneous equation. So let's keep this equation as first one. Then let's move on to the other one, that is t. So in the t, if we analyze the indices of the t or the power of t, in the left side you can able to figure out that the t having a -2 index or the -2 power. On the right side, t having a -2, but it should be multiplied from y, that is -2y. Then if you divide the both sides from -2, you can able to figure out that y equal to y. So y equal to 1. Right? So if you substitute the values for this first equation, then you can able to figure out that if you substitute the relevant values, 2 equal y, y mean 1 plus z. So the z should be 1. Right? Okay. Now, this is the final conclusion of this question. That is, now we have obtained that x is equal to y equal to y, and z equal to, sorry, x equal to 1, y equal to 1, and z equal to 1. So then, at the second step, we have derived that k equal m into the power of x, g into the power of y, h into the power of x. Then in the question they have mentioned that the k is equal to y. Then so this should be the equation: m into the power of 1, g into the power of 1, h into the power of 1. So then this can be expressed as E equal mgh. See, we already have idea about these equations now, right? So just raise your hand if you obtain this expression, or if you obtain this equation. Right, very good. Just raise your hand, guys. All right, very good. Great, brilliant. Okay, so this is the way that we obtain the equation by considering dimension analyzing, right? Okay, now let's take out tubes. Let's take this tube. This one, right? Physical quantities. Right. In the physical quantity tube, just turn the page number 11. In the 30th question. Page number 11. 30th question. Right. So try to obtain the answer for the 30th question. Right. So I want to tell you that. So in the 30th question, it is assumed that period of oscillation of a simple pendulum depends on the following quantities, right? So first of all, period of oscillations. Guys, period of oscillation mean it should be capital T, right? There's a small printing mistake in this. Period of oscillation is represented as a capital T. Now keep in mind that the period of oscillation is expressed as a time. So it is a kind of it's a time value, right? So when you obtain the dimensions, just keep in mind that it should be it is considered as this period of oscillation is considered as a time. Right. So let's go through the answer. The first few steps of this questions, right? So if you go through this question, you can able to obtain that the period of oscillations of a simple pendulum depends on the following quantities. First one is length of the pendulum. Second one, acceleration due to gravity. And the third one is mass of the bob, right? Guys, first of all, let me tell you what is the meaning of simple pendulum, right? So this is the simple pendulum. Now, this is called as the an bob, or it is an object. This is the string, right? So this string is attached to a particular surface and allowed to move this bob in this kind of motion, right? So you can able to obtain this motion in a grandfather's clock, isn't it? Right? So if you attach an object with a string to a ceiling and give some force, so then what happened? This object is moving this kind of motion. So that's the meaning of simple pendulum, right? Okay, right. So in a simple pendulum, the period of oscillation, that is capital T, is depend on length of the string and gravitational acceleration and the mass of the object, right? So then the first thing is you have to obtain the relationship between each physical quantity, that is T and L, T and G, and T and M, right? So let's write this as T proportionate to L into the X power, T proportionate to G into the Y into the Y, or G into the power of Y, and T can be expressed as M into the power of Z. Right, so these are the three relationship between time and the L, G, and M. So the next step is, you know that we can able to write this relationship by combining each other, that is L into the power of X, G into the power of Y, and M into the power of Z, right? So this is the first step. Now in the second step, as we discussed, we have to exclude this proportionate sign. To exclude this proportionate sign, we have to use a equal sign and a constant, and write down the rest of the thing in the expressions. That is right. So this is the expressions. Okay. Now this is the expression that we obtain in the second step, right? So the third step should be you have to substitute the dimensions for each physical quantity except the k, now a constant, right? So in the third step should be, now time mean, now t represent the time, so then the time should be substituted as t, right? So here I'm using dimensions, right? Not this capital T, equal L mean length. So the dimensions of length should be capital L and e to the power of x. G mean gravitational acceleration. So the dimensions of acceleration mean L t minus 2 into the power of y. Simple M mean mass mean capital M into the power of Z. Right. Right. So then now in the third step, we substitute the dimension for each physical quantities, right? Then the next step should be you have to analyze the fourth step. In the fourth step, you have to analyze the each dimensions, right? So now here in this expression you can able to figure out another fresh thing, that is, guys, just check whether is there any you can able to figure out that L, T and M dimensions are in the right side of this expression, but you can only figure out that only T in the left side, isn't it? So what should we do after from that point, right? Unless there's any dimension, that is M or L in the left side, how should we continue this simplification, right? So then, if there's a absent of the dimension in a particular side, you can able to consider that here it is T equal to Lx T minus into power of y and n into power of x, right? So, guys, if any instance, any absent in the dimension of a particular side, you can able to consider that this one as m into the power of t 0, L into the power of 0 and t. Right. Just notice this thing very carefully, because so is there any impact for the expression by applying m into the power of 0 or L into the power of 0? No, because m into the power of 0, the value is equal to 1. L into the power of 0 is equal to 1. So there's no any effect for the expression by applying m into the power of 0 or L into the power of 0, right? So then you can able to consider this one. So why we apply those two dimensions for this expression? Because in dimension analyzing, we have to analyze the m, L and T. But even L and M is in the right side. There's no any M or L in the left side. So because of absent of this M and L dimension in the left side, I put this M into the power of 0 and L into the power of 0, right? So there's nothing much more about that, but you have to be figure out, or you have to be concerned this point. In any instance, if there's any absent in the particular dimension in a one side, then you can able to put the 0 power of the considering dimension onto the other side, right? Okay, right. Then now let's analyze the dimensions of m. Now in the left side, you can able to figure out that the dimension, the power of the m is equal to 0. Then on the right side, you can able to figure out what is the power of capital M on the right side. That is Z, isn't it? So that's mean the x is equal to 0. Sorry, Z is equal to 0. Let's analyze the L. Then on the left side, the power of x L is 0. On the right side, we can able to find 2 points of L. Then the power of L in this position is equal to x. On the other side, it is 1, but it should be multiplied by y. That's mean plus y. You can able to obtain an answer by looking at this equation. So let's consider this one as the first one. Then analyze the dimensions of t. So in the left side, you can able to figure out that the power of t is equal to 1. On the right side, that is minus 2 into y. Right. That's mean the value for y is minus half. So this is the value for y. Now we have obtained a value for x, z and y, but we don't have a value for x, isn't it? So let's substitute these values into the first equation. Let's substitute y equal half for the first equation. Then you can able to figure out that 0 equal to x minus half. So when it's come to the opposite side, it convert into positive half, right? So these are the value for x, y, and z, right? So then the final thing is you have to substitute this value into the obtained equations, right? That is t equal k L into the power of x, x mean half, g mean minus half, n mean 0, right? So according to the questions, the constant of proportionality has been found as 2, 5, right? So that's mean, guys, the value of k should be equal to 2, 5, right? So if I further arrange this equation, this can be written as t equal k. So instead of k, we can able to substitute as 2, 5 L into the half, g into the minus half. So this is the equation, right? Guys, raise your hand if you obtain this equation. And guys, this is the obtained equation. So this can be further arranged, right? So this is the expected answer, right? So this is the expected answer, or you can able to arrange this expression as by by taking the only the positive powers, right? To obtain the positive powers, I'm taking this g into half into the denominator position, right? So this can be also accepted. Further, if you are willing to design this equation, keep in mind that half power always uh, express or represent the root, right? So this can be written as t equal to 5 root L over G, because this half power is relevant to the L as well as the G. So instead of half power, I can able to substitute the root sign, right? So all of these answers can be accepted as the correct one. Right. After completing this question, let's move on to the 36th question. 36th question in the 12th page. Right. Just complete this 36th question. Keep in mind that tension is a force, right? Tension is a force. So the dimensions of tension should be M L T into the power of minus 2. Same as the dimension, same as the force, right? Right. So let's go through the answer. Now in the 36th question, it has been found that the velocity of a transverse waves along a stretched string depends on the following quantities, right? Right. So that's mean that you don't have to understand every single word of these questions, right? But the thing is, you have to just to grab this. That is, the velocity is depend on the following physical quantities, right? So the velocity depends on the following quantities. That is, the first one is the tension on the string, tension in the string. Second one, the mass of the string. Third one, length of the string, length of the string, right? Okay. Now, according to normal procedure, the first step should be we have to build up relationship between each physical quantities with the velocity. That is, v proportionate to t into the power of x, v proportionate capital M into the power of y, and v proportionate to the L into the power of z, right? So this, if I combine these three expressions, then we can able to obtain that v proportionate to t into the power of x, m into the power of y, L into the power of x, right? So guys, this is the this is the first step, right? So then after that, the second step should be excluding the proportionate sign by applying an equal sign and a constant. Then we can able to arrange this equation as f equal to k t into the power of x, m into the power of y, L into the power of z. So this is the second step. In the third step, you just have to substitute the relevant dimensions for the each physical quantity, right? So the v mean velocity, so that's mean lt minus 1 equal. Now when you substitute in the dimension, you can able to ignore the constant. And t means, guys, as I mentioned earlier, t is a tension, so it should be a kind of a force, right? So the dimensions of tension should be m l t minus 2 into the power of x. Now m represent the mass, so the obviously the dimensions also is equal to capital M into the power of y. L represent the length, so the dimension should be capital L into the power of z. Right. So now we have completed the first three steps in this questions, right? So then the fourth one should be we have to analyze the dimensions, right? So guys, now here you can be able to identify that in the right side of this expression, you can be able to find out three types of dimensions, M, L, and T. But on the left side, only two dimensions can be identified, that is L and T. There's no any capital M in the left side. So if there's an absence of dimension which is in the expression, you can able to substitute it as m into the power 0, right? So here you notice that there's no any, but m is on the right side but absent in the left side. So that's why instead of m, I can able to arrange m into the power 0 lt minus 1 . Right. See, now you should have an idea about these stuffs, right? So in the previous question, we have learned that if there's an absent of particular dimension, you can able to substitute without damaging or without affecting to the equations, right? Okay. Now we are going to analyze the dimensions. Let's initiate from 0, from m, right? So in the left side, the power of m is equal to 0, right? Equal on the left side, sorry, on the right side, you can able to find m in two positions, isn't it? It here and in this point. So in this, it is consist of e to the power 1, and this 1 should be multiplied from x, that is x, and the dimension, the power of the other m is y, right? So it is considered as plus y because is given as a plus positive value, right? So then we can able to derive that 0 equal to x plus y. So let's consider as the first simultaneous equation. Right. Let's move on to the other dimension, that is L. So in the left side, you can able to find out that the dimensions of the L, sorry, the power of the L is equal to +1, isn't it? It is +1. On the right side, you can able to find out L in two positions. Here it should be 1 into x. So that's mean x. On the other side, it should be z. Right. Oh good. So this is also uh, is considered as the second simultaneous equation. So by considering these two, the initial two equation, we can able to find out any value for find out any value, right? So that's fine. Let's move on to the other one. That is, let's consider the dimensions of analyze the dimensions of t. So in the left side, the power is in the t is equal to -1, equal to on the right side t is only mentioned at this point, so it should be -2. The power is -2, but it should be multiplied by x, isn't it? So it should be 2 minus 2x. Then to obtain a value for x, I divide these both sides from -2. That's mean x equal to half, right? So that's mean x equal to half. Okay. In order to obtain the value for other uh, unknown terms, let's substitute the obtained value for the first and second equation. So if I substitute the obtained value for the first one, that is x equal to half, substitute for the first equation, then 0 equal plus half plus y, then y should be equal to minus half, right? If I substitute the value of x into the second equation, you can able to find out that 1 equal half plus z, then z should be 1 minus half, that is equal to half. Right. So now we have already obtained the value for each unknown term, that is x equal to half, y equal to minus half, and z equal to half, right? So let's substitute these values for the obtained equation in the second step, right? That's now here they have mentioned that the value for k is equal to 1, right? So then it should be now, this is the obtained value now, right? So when you substitute in the values, you can able to neglect the k because k value is equal to 1, t is half, m is minus half, n is plus half, right? So this is the obtained answer. If you obtain this answer, that is the correct one. But you can able to arrange this expression further, right? So here there's a minus power. So in order to convert this positive, I'm taking this m half into the denominator position. So it can be written as t half L half over m half, right? So this can be also can be considered as the correct one. So, but we can able to further arrange this expression. That is, previously I mentioned that half power represent the root sign. So each term, each signs consist of half power. So that's mean instead of this expression, I can able to arrange this one as TL over m root TL over m, right? So any of these answer can be considered as the correct one, right? Okay. So guys, so today we will discussed about the uh, deriving the equation by considering dimension analysis, right? So I think you have get this lesson clearly, and so in the next day, let's move on to some other questions, and I will upload you some question to the group, and you have to derive the equation uh, for the considering questions, right? Okay, so that's in for the today. So have a great day, right?